So today we are going to solve this problem, Decode Ways. So in this problem we are given a string of numbers, okay, string of numbers, and our job is to find how many different ways we can convert this number string into letters. Okay, so let's understand the problem. See, each letter has a number like A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, and Y, Z. Okay, each letter has a number like 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and last 26. Okay, so see, in this problem only numbers from 1 to 26 all valid. Okay, 1 to 26 numbers only valid, so that's very important. So see, if we have input like is string 1, so 1 is only A, so there was only one way, so the answer is 1. Okay, we can convert this string only one way, so the answer is 1. That's all. If we have input like 12, so see, now we can split it into two ways. Take one digit at a time. First we take one digit at a time. So see, 1 is A and 2 is B. 1 is A and 2 is B, so the result is A, B. So if we take two digit together, like 1 and 2 is 12 is 2A. 12 was L. So there are total two ways. Okay, so the answer is 2. So in this, see, so the answer is 2. We have two ways. Okay, so that's only the problem was saying. So let's take another example. If we have 2 to 6, if we have string like 2 to 6, see, 2 to 6 means 2 is B, 2 is B, and 26 is 2, 26 is Z, and 22 V. 6 and 6. See, first is 2. Let's see, 2 means it can come B, B, F. If first, okay, B, 2, 2, 6. 2 is B, B, 6. Next, this is one way. Next, 22 and 6. What is on 22? V, and 6 F. So next is 22 and 6 was V and F. V and F. Next is 22, 2 and 26. 2 is B and 26 is Z. Okay, so there are three ways. Okay, so there are three ways. This, what is this? 2 to 6. So there are three ways. Which one? B, B, F, V, F, and B, Z. B, B, F is 2 to 6. 2 to 6 is 2 to 6. So 2 and 26. So there are two ways. So the answer is 3. Okay. Now see, 0 cannot stand alone. Okay, so 0 is numbers are starting from 1, so our alphabets are starting from 1, okay, not 0. So 0 is invalid, and 0, 6, 0, 5, they are all invalid, okay. So 0 must always come with 1 or 2. So see, 0 is invalid, 0, 6 are invalid, 0, 7 invalid, like 0, 6 invalid. If 1 0 come, it was valid, 2 0 come, it was valid, okay. So let's understand the problem. You are given a string of digits, okay, and each number from 1 to 26 map to letters 1 to 26. To 1 to 26 maps to a letter, you must count how many different valid way you can break the digits into number between 1 and 26, okay. So that's it, nothing more. So let's take 1 2 1 2 only. First example, 1 2 1 2. So let's make a tray. See, if we take one digit, if we take 1, if we take 2, so if we take 1, it's look like this. But if we take 1, so it's like 2. If we take 2, it's like just empty string. If we take 1, it was empty string last. So see, we are at first digit 1, okay. So we have two choice. Take one digit, take one digit, that was A1. Now remaining string is 2, okay. Now remaining string at 2. From 2 again we check, take one digit B, okay. Now remaining string is empty, so that means we found A and B, so one full valid decoding, okay. So next choice is take two digit. If we take two digits 1 and 2, so it was L. Now remaining string is empty, so we found L, okay. So second valid decoding is L. So this for one digit. Let's take the digits. If we take 1, if we take 2, this was strings, okay, 2. And if we take this was end, so this is also end, okay. So see, 1 2 and A B, so the answer is A B. Second is 1 12 and that was L, so it was L. So total we have two ways, okay. So the answer is 2. At every time we see our numbers, we can either take one digit or two digits. Each choice creates a branch. Every branch that reach the end in one valid decoding, okay. So let's take another example. If we take 1 2 3, okay. First remember 1 2 3 now. Let's see, 1 is A, 2 is B, 3 is C, and 12 is L, and 23 is W. So let's make a tree of this. If we take 1, if we take 1, so it was 23. Two choice. If we take 2, if we take 23, this we have 3, and if we take 3, if we take 3, so it was end. Now this 23 is last, so it was end. If we take 12, if if we take 2 ways, so 3, remaining was 3, and if we take 3, so it was end. Okay, so see, so let's make, I have to write here. Okay, 1 2 3. So if we take 1, if we see, take 1 23. Okay, if we take 1, it was 23, and if we take 2, so it was 3, and if we take 3, so it was end. So letters are 1 2 3, A B C. So result is ABC. In second part, if 1 2 3, if we take 1 23, if we take 23, so it was end. So the letters are 1 A, 23 is W, so the result is AW. Okay, in part 3, 1 2 3, if we take 12 and remaining is 3, if we take 3, so it was N, so 12 is L and 3 is C, so result is L and C. Okay, so there are total 1 2 3, A B C, A W and L C, so there are total 3 ways, so the answer is 3. Okay, let's take another example. If we have which one, 101. Okay, so 10 is J and 1 is A. So 0, see, 0 alone is invalid. Okay, so if we take 1, if we take 1 0 1, so 0 has come first, so it was invalid. Okay, invalid. If we take 10, if we take 10, so 1, so if we take 1, so next was end. So see, if we take 1, 0 and 1, 0 and 1 is invalid because 0 cannot start a number, so it is die. Okay, in right side see, if we take 10, so 1, and if we take 1, it was and, so letters are 10 is J and 1 is A, so there are 2 ways. No, so there are just one way, J and A. Yes, so there are just only one way, so that was J and A. Okay, now every node split into take 1 digit if valid, take 2 digit if valid. Every branch that reach n is equal to 1 decoding. So that's it. So see, let's try then. If string is 1 2 3. Okay, so we are solving using function. So function means solve of I means from index I how many decoding ways are possible. Okay, so see, 0 1 2. Okay, so the length is 3. Okay, so we start from 0, solve of 0. So we start from solve of 0. Okay, we are at index 0 and character is 1, and we can take 1 digit. Yes, can we take 2 digits? Yes, because 2 is valid. Okay, so we split into 2 calls, and that was ways is equal to, solve of 1 plus solve of 2. Okay, now we calculate it one by one. Okay, so next solve of index 1. Now index 1 is character is 2, so can I take one digit? Yes, because 2 is valid. Can I take two digit? Yes, because they are also valid. So see, so solve of 1 plus solve of 3, so it's called like this. Solve of 1 is equal to, wait, solve of 1 is equal to solve of 2 plus solve of 3. Now we go deeper. Next is, so it index 2 character is 3. Can it take one digit? Yes, because it 3 was valid, that was C. Okay, can I take two digits? No, nothing after 3, so I cannot take two digits. So solve of 2 is solve of 3. Okay, see, now index 3. So now index is equal to length. Okay, that means we decode whole string successfully, so we have just written 1. Okay, see, whenever we reach end, it means one valid decoding is founded, so that's why we have to return 1. Okay, now solve of 3 is equal to 1. Just see, solve of 2, so solve of 2 is 1 because there are one valid way. Now we solve, come here, so we had solve of 1 and solve of 2 plus solve of 3. So we know solve of 2 is, so we know solve of 2 is 1 and solve of 3 is 1. So solve of 1 is, so solve of 1 is 1 plus 1 is 2. Okay, 1 plus 1 is 2. Now we back to solve of 0. So solve of 0 equals to, so see, solve of 1 is 2 and solve of 2 is 1. So solve of 0 is 2 plus 1 is 3, so the answer is 3. Okay, at every index, if digit is not 0, we call solve of I plus 1. If two digit number is between 10 and 26, so we call solve of I plus 2. If index is equal to length, that means we have to return 1. Okay, so see, in and why we have to return 1, because researching n means one full valid decoding part is completed. Okay, and then so every part give 1 and them all. So let's take another example. This one, let's take another example. If we have 101, okay, 1012, so the length is 3. So solve of 0 means how many ways from index 0. Okay, solve of 0 means how many ways from index 0. So let's make a tree. If we take one digit, if we take 1, so solve of 1 is invalid. No, solve of 0, if we take one digit, solve of 1 digit, it was invalid. If we take two digits, I think it was, first we make a tree. Okay, two digits, so solve of 2 and solve of 3, it was 1. So see, solve of 0 is 101, index 0 and character is 1. So can I take one digit? Yes. Can we take two digits? Yes, we can take 2 digits. So wait, just a second. So see, index 0, character is 1, so can we take 1 digit? Yes, 1 is valid. Can we take 2 digit? Yes, 10 also valid. So see, solve of 0 is solve of 1 plus the solve of 2. Now we calculate both. Next is 1, index 1, so character is 0. See, if what we do, if string of I is equal to 0, okay, we have to just return 0 because 0 cannot be decoded alone. There is no return for 0. Okay, so solve of 1 is 0 left branch, so that's why left branch is that. Next is 2, index 2 and character is 1, so can we take 1 digit? Yes, because 1 is valid. Can we take 2 digit? No, because nothing after it. Okay, so solve of 2 is equal to solve of 3. Now step index 3 out of bound, so in index is equal to len, that means we successfully decode whole string, just return 1. So solve of 2 is 1. Now we had solve of 0 plus 1 and 2, so solve of 1 is 0 and solve of 2 is 1, so 0 plus 1 is 1, so the final answer is 1. Okay, so only one valid decoding is 10 is J, 1 is A, so J A. Okay, so 0 alone is invalid. 0 much cannot comes with 1 or 2, so only 10 or 20 are valid. Okay, so see, if you take 1 2 3, you can stand on 1. Okay, you have 2 choices, take only 1, take 12 together. Okay, if you stand here, okay, if you stand here, you have 2 choices, take only 1, or take 12 together. That's it. Okay, see, so if your string is, so if your string is 12, okay, so 12 how many ways? So we should say 12 is A and B and 12 is L, so total 2 ways. So how did we get 2? Because ways of 12 is equal to ways after taking 1 place ways after taking 12. So we convert this thinking into function. So see, so solve of I, okay, means from index I to how many ways. So we write a function in recursion, int solve of string now. See, this function tell how many ways from index I. Next is, see, next what, if index position 0 and 1 or 2. So if we reach index 2 after finishing string, that means we made only one valid decoding. Okay, so we write if I is equal to s dot length length return 1. Okay, when we reach end, return 1. Next is if see what we do. If a current digit is 0, if we have different type of string, 0 1 they give, 1 0 they give. If we have this type of input, what we do, if a current digit is 0, invalid. Okay, current digits of 0 is invalid. So if you see s is equal to 10, so at index 1 0 1, so 0 is alone, cannot decode, so we write, see, that's how we write. If s of I is equal to 0, return 0. Okay, see, at index 0, which 12 now, let's make a clean page. So we have 12 0 1. At index 0 we had two choice, so we create to 0. Okay, so see, from index 0 in 12, so take 1, then move to index 1. So we write, so how we write this, base press wave pressure equal to solve of I plus 1 s. See, this line means take one digit and move, and take one digits and solve remaining. Okay, second choice we have, take what, two digits possible. If see, in 1 2, if we take, it was valid. Okay, so we check, how we check, see, we check like this. If it was valid, okay, I plus 1 is less than s dot length. So then from numbers, int num is to s of I 0 into 10 plus s of I plus 1 0. If or next is, if between 10 and 26 we have to take numbers. If num is greater than or equal to 10 and num is equal to 26, okay, 26 base press is equal to solve of I plus 2 and s. So this means take two digits and jump 2 steps. Okay, now we just return ways. Return server 0,s. Yes. See, recursion idea is correct, but the problem is it repeats same work again and again. Okay. So for this we are going to use memorization. So you all know what is memo do. Memorization means if we already solve from index I, do not calculate it again. So we just told answer next time return directly. For this we are going to use map. So UNORDE unordered map int comma int memo. Okay, so see, this key index and value is number of ways from that index. Okay, from that index. So 0 0. Next what we have to do, if already calculate, if next two ways we have to take one digit, next we have to take two digits and number formula. If num is already, then just return ways. So what we have to just return, so no, return memo of I is equal to ways. So it's work, but sometimes we cannot use memorization also. So now we going to use tabulation, bottom up dp. Now we move, see, now we remove recursion completely. Okay, so we build answer from back. Okay, we build answer from back. So for this, just say just a second. See, in recursion we have same logic idea. So same formula we use. Ways of I is ways of I plus 1 plus ways of I plus 2. Okay, so let's start. So if your string is 1 2 3 4, so n is equal to 4. Let's take another and green part. Okay, so s is 1 2 3 4, so n is 4. So see, dp of I means number of ways from index I to n. So because recursion formula was what? Recursion formula was ways of I equal to w ways of I plus 1 plus ways of I plus 2. So instead of calling function again and again, we store answer in one array. Okay, we store answer in an array. So that array is dp. So we need one box for every index. Okay, indexes are like see 0 1 2 3. So that position is 4, but wait, we also need answer for I is equal to 4, because when we reach end we return 1. So total we need 4 boxes. Okay, so 0 1 2 3 4, that's 5 boxes. So why we use n plus 2? N is 4, so you might think we need only n plus 1, but look carefully. Formula says ways of I plus 1 and I plus 2. At I is equal to 3, we will access dp of 4, that I plus 1, and dp of 5, that I plus 2. So we need safe space for dp of 5. Also, even if we do not use it much, it prevents out of bounds. That's why we use is equal to vector is a table or vector in dp of n plus 2 0. So see, n is equal to 4 and size is 6. So the boxes are 0 1 2 3 4 5. Okay, now it's safe. So next, why we need base case? So what is the base case? dp of n is equal to 1. See, if we reach after last character, now so how many ways? If example this and index is 4, so we decide whole string successfully, that is one valid way. Okay, so dp of 4, see, dp of 4 is 1. So this is exactly same as recursion base case. Okay, if so it's the same as recursion base case. No, if not, dp of n equal to 1. dp of n is equal to 1. Yes. Next, so see, I think first we have to write code. So see, if so we calculate from left to right at a is I is equal to 0. Okay, so dp of 1 and dp of 2 are not calculated yet. So the problem is, so we go backward, start at last index. So when we compute dp of I and dp of I plus 1 and dp of I plus 2 are already ready. So that's where we write backward row. Okay, for int I is equal to n minus 1, zero I minus minus. Okay, see, so if we use s of I is equal to 0, so 0 is cannot map to any letter. There is no letter for 0. So if current digit is 0, so there are 0 ways. Okay, so we just written 0. We have done here also same logic only. Okay, if s of I is equal to 0, so dp p of I should be 0, and just continue. So next we write dp of I is equal to dp of I plus 1. So see, why dp of I plus 1? So this representation taking one digit. Okay, if we take one digit, which digit we have? 1 2 3 4. If we take one digit and we move to next index, number of ways from their digit is dp of 1. So dp of I is equal to dp of I plus 1, means all ways that start by taking one digit. Okay, next see what we do. If I plus 1 is greater than s dot size int, so it was same logic we use for 10. dp of I yes. See what we are doing in this dp. Okay, so we add dp of I plus 2 if 2 digit from valid number. Okay, if 2 digit from valid number, that was 10 to 26, so we can jump 2 step. Okay, number of 2 ways, so from there is dp of I plus 2. Means I add ways where we take 2 digits. Okay, now every position I we ask, can I take 1 digits? Yes, if add dp of I plus 1. Okay, where is dp of I plus 1? dp of I plus 1. And can I take 2 digits? Yes, if valid. If it was valid, we can add I plus dp of I plus 2. That's it. Okay, so see the code. This code is tabulation code, and this is first recursion code, next is memorization code.